In this question, you're being asked to give the expected major product or products of each of the following reactions, and if no reaction is taking place, write no reaction. Like I said in the previous examples, we are in lecture 14, which is SN2. We have yet to talk about all the competing reactions, and therefore we're not going to look for those competing reactions right now. We're just going to focus on SN2, or it's no reaction. So same steps as always. We want to evaluate the substrate, the leaving group, the nucleophile, the solvent, and the sterics of the substrate. So I like to find that leaving group first. Here we have a bromine on a carbon. Bromine is probably our leaving group here. It's a great leaving group. This carbon here is secondary. It is a secondary substrate, still capable of undergoing an SN2 reaction. This methoxy substituent, oxygen, not a good leaving group in this case because that oxygen leaves with negative charge, and that negative charge is just stuck on that oxygen, and the bond between carbon and oxygen is a relatively strong bond. So the methoxy group is not a good leaving group. Chlorine here, chloride, has a full negative charge. That is our nucleophile. It is dissolved in an aprotic solvent called DMSO. Just be familiar with that. You're going to see that a lot. DMSO just means an aprotic solvent. All right, so let's evaluate this. So we have this secondary substrate with a good leaving group, still capable of undergoing an SN2 reaction. We already know that bromine is pulling electron density from this carbon, which I'm dotting in red. So that is most likely where the nucleophile is going to attack, because that is where our partial positive is building up. All right. So what could potentially happen here? Well, that nucleophile, the electrons on the chlorine, can attack that red carbon, and that can kick out the bromine, because remember, that red carbon can only have 4 things bonded to it. It has a hydrogen that's not shown, it's bonded to 2 other carbons, and it's bonded to the bromine. Something has to leave, and it is going to be that leaving group, which is the bromide in this case. All right, so we can't just simply go ahead and put the product here because there's some stereochemistry involved in this example. Because this methoxy group, it is on this side of the ring. So right now I have it on a dash, which means it's going into the paper. The bromide is also on a dash in this starting material, so it is also going into the paper. And we know that in an SN2 reaction, that nucleophile, chloride in this case, it's going to approach backside, meaning opposite side of the leaving group, which means that nucleophile is attacking that red carbon from outside of the paper. And when it does that, it's going to repel. Let me draw this hydrogen in here. That hydrogen is actually coming out of the paper right now. When that chlorine comes in and attacks, it is going to kick out that bromine. That hydrogen is going to repel into the paper. So I'm going to now draw the hydrogen over here on a dash. And that chlorine that added from outside of the paper, which means it's going to be on a wedge. The point is, notice the relationship between the chlorine that added and the methoxy substituent that was already there. One is on a wedge, one is on a dash. They are on opposite sides of the ring. So this is the product that you're most likely to get. If you were, and I'm going to draw this, but you should not. If you were to draw this as your product, that says the chlorine and the methoxy are on the same side of the ring. That would be incorrect. So you don't want to draw that one. So yes, we do have to pay attention to that stereochemistry there. That would be the final product of this reaction.